Hello and welcome. My name is Matthias Anderson. I'm one of the developer advocates at Pluralsight. And today we are at the Author Summit at Pluralsight headquarters. I have with me two Java champions. I have Jose and Morris, and they're going to talk today about Java 19. So I'm going to let you two take it away. So go ahead. Do you want to start?
So Jose has been doing a lot of talks and specializing in his understanding of the new features in Java 19. So I understand what you want to tell us about today is going to be like records and the new features of records that have been introduced, and about pattern matching and about Loom. Am I
Absolutely,
right?
yeah. Java 19 is going to be released next week, actually. I think it's Tuesday, to be precise. And as usual, we have a bunch of new features, bug fixes, etc. in it. And we have, I think, the two most exciting features of Java 19 are these new steps towards the implementation of pattern matching in Java, which is record deconstruction, which allows you to take a record, build on components, and create a pattern with this the name of these records, and the components, and the component become binding variables that you can use later in your code. You'll be able to use that in the instance of stuff, for instance, and the switch, the switch expression that has been introduced a while ago already. It's a preview feature, so it's really great to have that, and I think it will further simplify the code we are going to be able to write to analyze stuff and deconstruct stuff. And at the first step of deconstruction, there's more to come, more places in your code where you'll be able to use this feature, which is going to be really great. So that's the first feature of the JDK 19. And the second big feature, probably the most anticipated feature of the JDK 19, is the first release of the Loom project. Now, this release is made up two parts. The first part is called virtual threads. So virtual threads are going to make it in the JDK 19 as a preview feature. And the second part is something that you can use for virtual threads, which is structured concurrency. And structured concurrency is kind of a preview feature, but it's called really an incubator API. It's almost the same as a preview feature. It's just a different name and a different details.
Isn't an incubator feature earlier in the stage of development than a preview feature?
Well, yeah, preview feature are about the language, and incubator features are about the API. It's not really a golden rule, but it's kind of working like that. Yeah, absolutely. We have other incubator APIs that have already been added.
So with this pattern matching, we're getting nearer and nearer to the pattern matching that functional languages have been offering since forever.
Absolutely. I mean, pattern matching is not a new idea.
No, not at all. So what would you say was the kind of broad approach of structured concurrency that Loom is going to introduce?
So structured concurrency is really about being able to use the million of threads that virtual threads will allow you. Currently with platform threads, you can launch something like several thousand threads on your machine without blowing it up. Because
depending on your machine.
Depending on your machine.
Not all machines will tolerate that.
Absolutely. But basically, a platform thread is about 2 megabytes in memory in Java. That's the consumption of platform thread. Launching a platform thread takes roughly half a second, but it's in the order of hundreds of milliseconds. And switching from one platform thread to the other, when you're doing context switching, is about in the order of the milliseconds or milliseconds.
So with all this stuff, sorry, excuse me. So with all this stuff, you're at the mercy of the platform, basically.
With this kind of stuff, yes. If you have a really big and beefy server, you may be able to launch several thousands of platform threads, maybe tens of thousands, but that's really the order of magnitude you may have.
And the overhead they'll take will be dependent on the platform.
Yeah, absolutely. It depends on the operating system, on the platform itself. But if you consider that when you're doing some I/O, for instance, you're doing an HTTP request in a thread, consider that your thread is idle 99.9999% of the time.
Idle.
Yeah.
Idle.
Idle. It means that if you want to keep your CPU busy above 90%, for instance, you will need probably close to 1 million threads, which is a 2 terabyte machine.
Yeah.
And launching 2 million threads will take you something like 20 minutes. Okay, so it doesn't work. Basically, it doesn't work. So you need another model. And that's why asynchronous programming is a thing today. It's because what you want is a thread that is non-blocking, that is doing very few stuff very quickly so that you can keep your CPU busy with the threads you have. But now with Loom, you have virtual threads, and a virtual thread is a completely new model. It's something new. I think the only other language that has virtual thread is Erlang. Am I pronouncing that correctly?
Erlang, yeah.
Erlang, yeah.
Mm-hmm.
The idea is not new, but it hasn't been implemented in many languages. Java is the second, to my knowledge, Java is the second language to implement that. Basically, it turns out that when you consider the whole call stack of your platform thread, you have your platform thread, and then at some point, this platform thread is going to launch a virtual thread. So you have the call stack of this virtual thread, which is much smaller than the full call stack. And a virtual thread in Loom, when they block, there's an internal mechanism that will take the stack, particular to this virtual thread, and move it to the heap memory. Okay, so it frees up the platform thread that is running this virtual thread, and it makes this platform thread available to run another virtual thread. So now, what is the price of creating a virtual thread? Well, it's much lower than a platform thread because the stack is much smaller. It's in the order of the tens or hundreds of kilobytes instead of megabytes. So that's a huge saving in memory. And the price of blocking a virtual thread is now just the price of moving the piece of memory from the stack to the heap. So it's also much, much cheaper to block a virtual thread rather than blocking a platform thread. So it means that when you write your code, you don't need to write non-blocking code anymore. Writing synchronous blocking code is perfectly fine.
Yeah. So we're really getting back to the original model of concurrency that Java threads were intended originally to implement.
Yes, absolutely.
And were really quite a lot simpler than the reactive programming that we've had to resort to.
Reactive programming, as we know it today, is really about writing callbacks within callbacks within callbacks within callbacks. If you are not convinced by that, just type in callback hell in your favorite search engine. You will have good examples of that. It's super hard to write this kind of code. It's super hard, if not impossible, to unit test it because you have race conditions all over the place because all the lambdas you're writing are executed in their own thread. It really becomes a nightmare. And it's, I think, impossible to properly profile this kind of code.
You do realise, don't you, that that now that you've said that, there'll be a mob with torches and pitchforks outside?
Well, I already saw this mob, in fact. So yes, I know that. But I mean, that's the way things are evolving.
Yeah.
I mean, asynchronous and callback-based programming has been a thing for many years, and it has been doing a great job for many years. It has drawbacks. It has a cost. Now this new model kind of arises. Okay, we need to evaluate it. We need to see how people are going to use it in their application. And if it works, then we will be able to stop writing this kind of asynchronous code, which I think is a great thing. Now, there's no magic wand in programming. We all know that. I'm not talking about creating some kind of magic device. Okay, it's not the case. But we need to evaluate that on real application and see what people are doing with it, really.
So what's the trade-off then? I mean, nothing comes for free.
Nothing comes for free, but really the trade-off is getting rid of this kind of code and being able to write much simpler code at a much lower cost. That
doesn't really sound like a trade-off to me. That sounds like
a win-win.
A benefit, a win-win. Yeah.
Yeah, absolutely. It does sound like that. So we need to see that.
Well, we'll see. We'll have to see. You quite often, when you have an innovation as radical as this, you don't actually really know how it's going to work out in practice, even if you've thought it through as well as you can do.
Yeah, absolutely.
When hundreds of thousands or millions of programmers get their hands on it,
absolutely,
you get very different results from the ones you expect.
It will come at a cost that. Yes, there is a cost. For instance, currently, when you're doing some debugging in your IDE, you have this little panel with all the threads that are currently run in the JVM, and you have like 10, 20, maybe 50 of them, maybe 100 of them. Yeah. So if you want to know which thread is running with your task, it's quite easy to find your way there.
It's a model that's really easy to understand.
Yeah, absolutely. If you have 1 million of them, I'm not even sure that
Yeah.
this
Be
panel will.
scrolling for quite a while
Yeah,
there.
absolutely. You're good. You need to have a good finger.
Yeah, exactly.
And a good mouse for that.
Yeah.
But it can take a while to find the right thread that is running your task. So we have this model of structured concurrency, which is going to package these threads together in a new object called the structured task scope.
Say it again.
Structured task scope. I like to call it
Structured task scope.
structured task scope. Yeah, I like to call it scope because it's simpler. which is some kind of, it looks like an executive service for people who are familiar with that. That is, you submit tasks to this object and you get a future that you can analyze. But in fact, there is one big difference between an executive service and this scope object, which is that an executive service you're launching when your application launches, when you launch your application, and it shares the life cycle of your application. That is, the idea is because these platform threads are so expensive, you create them in your executive service, you keep them, and then when your application dies or reboots, then you also reboot this executive service. Now, because the virtual threads are much cheaper, it's also useless to try to pull them. So in a scope object, there is no virtual thread. There's nothing. When you submit a task to a scope, it creates a virtual thread to execute this task, and once your task is done, complete, either normally with the results or exceptionally with an exception, this virtual thread dies, and that's fine, and you get the results. So I think that this scope object, in fact, can also implement some business rules, simple business rules, and even launch other scope objects. That's why it's called structured concurrency, because a scope can spawn other scopes, that cannot spawn other scopes, etc. And when you shut down a scope, all the scopes that have been spawned by this scope are going to be shut down too. So that's a new model that is really based on the fact that virtual threads are cheap to create, well, at least much cheaper than platform threads, and cheap to block. So you do not need to avoid blocking virtual thread. There's no point in doing that, really.
So it can definitely offload some of the responsibility then for developers to have to restructure the way that they're writing their code to instead allow the platform to support them to write more straightforward code and get their code written more quickly. So that sounds like a really interesting thing. So that's Java 19 is being released next week, you said? Was it Tuesday you were thinking?
I think it's Tuesday. I think it's the 20th of September exactly. So is that Tuesday? I think it's Tuesday.
Not sure. I'd have to check the calendar. Yeah.
We need to check.
Yeah, it is.
It is. So
Okay.
it's Tuesday. Yeah.
Ah, excellent.
So we'll have that. So if you want to check how Loom is working and your application is doing some kind of concurrent programming and it's based on an executive service, Loom also comes with a special executive service that is going to create virtual threads on demand instead of pulling platform threads. So it's very easy to refactor your application and just to test that, to see if it works. Maybe it will not work that well for you because what you're doing doesn't fit the Loom programming model. It's really about introducing a new programming model, this Loom project.
So it will take some time for people to become more familiar with it,
Absolutely.
to start using it, and as you were mentioning, we'll discover things when people start using it more in more significant tasks. So yeah, very interesting.
And that's all the point of having preview features and incubator features, right? Because if the people that are developing this project, the Loom project, realize that something is not quite right, because it's a preview feature, it can change, it can be patched, it can be fixed. So but at some point, I think that what's important is to get feedback from the community. People are going to see them, going to use that, and hopefully at least some of them will provide feedback to see if it can be improved or fixed or whatever.
Right.
Excellent.
Okay.
Well, really appreciate you both joining us. So,
Well, thank you.
You both have made courses on Pluralsight on Java.
Absolutely.
So people can find you. Do you want to give your names and just a quick sort of where people can find you then? So that
You can find me as Maurice Naftalin.
Okay.
There's not very many Naftalins
There you go.
on the Pluralsight platform.
Okay. Yeah. Awesome.
My name is Jose. My last name is Pomard, P-A-U-M-A-R-D, so that's a French name, so it's really weird to pronounce it in that way. And I have courses on Pluralsight on the Lambda expression, the Stream API, concurrent programming, these kind of things. So, and asynchronous programming also.
Excellent.
So people can find that.
I think you
quite
were
easily.
mentioning that you had also done a YouTube video recently.
Yes, absolutely. I also, well, I have several YouTube video. I am the bartender of a series of video called the Jeb Cafe.
Oh.
Okay.
Uh-huh.
So if you just type in Jeb Cafe in your favorite search engine on YouTube, hopefully, you will find yes, the series of videos of Jeb Cafe. I like to talk about new features of the Java platform. I have several videos, including live coding sessions with virtual threads and structured concurrency. So if people are interested in that, if you're interested in that, sorry, definitely check them out.
Yeah. Yeah.
And,
Okay.
yeah.
Well, thank you both so much for joining
Thank
us.
you.
We really appreciate that, and hope you guys have a great rest of the Author Summit here. And
Definitely.
we'll hope to bring you even more people. I know we've got some more things scheduled for tomorrow. I'm not sure. We may even have some more today. But stay tuned. Keep watching, and we'll pop up on your notifications with some more live streams like this. So, thanks very much. Have a great day.
Thank you.
Thank you very much.
Thank you
Thank you.
both so much.
Thank you.